Hi, my name is Dr. Ramses Alcaide, and I'm the CEO of Neurable. At Neurable, we work with brain-computer interfaces in order to allow you to interact with your technology seamlessly. And today I'm going to talk to you about invisible interfaces. So what is an invisible interface? Well, an invisible interface is any type of system that allows you to control your technology without the use of a graphical user interface. So no buttons, no folders, no pathways, basically an invisible way to interact with your technology. The most common type of invisible interface is audio. And when you think about audio, we're primarily speaking about Alexa or Siri or these other virtual assistants where you prompt them and you speak a command, and then from there they're able to interpret that information and correspondingly react to it. But there's far more than just virtual assistants that are invisible interfaces. Another example of this is gesture. So in this example, we have BMW's gesture control system for their cars. In this case, the user, using their hand, is able to move it, and the system is able to recognize whether he wants to increase or decrease the volume, change the music track, or do any other sorts of commands for the car. This allows the user to be able to interact with the car and its settings, but keep their eyes on the road, keeping the driver safe. Now, when we're looking at these interfaces, you might say, well, these all seem like nice to have. We don't actually fully need these types of technologies. So when we look at invisible interfaces in the future, we ask, why are they so important? And in order to understand this, we have to understand the history of compute. So in the past, we used to have large mainframes in order to compute information. Then as technology developed and got smaller, we got to desktops, and from desktops we moved to laptops, and now we have powerful computers, more powerful than the computers that took us to the moon, in our pockets, and those are our smartphones. And as we move even farther forward and technology becomes more and more miniaturized, we start to get to wearable technology. Imagine devices that have the compute potential of a phone, but they fit in your ear as earbuds or headphones, or they're augmented reality glasses that also overlay information for you. This is the future of compute. And as we start to move down these directions, the need for interfaces that don't require a graphical user interface becomes far more important. However, there's still issues. For example, voice right now is still incredibly cumbersome to use, awkward, and it creates a lot of issues as an individual tries to use their technology in everyday life. There's actually three key issues that exist right now. The first one is private controls, being able to command something privately without others knowing. The next one is intuitive controls. Prompting everything or doing large gestures is incredibly disruptive. And the last one, which is a lot more subtler, is that these devices aren't able to do anything proactively. They're not able to understand a user's intent and take that into account to proactively create actions for the user, making their life more seamless and natural. So I'm going to take you through each one of these and explain to you the big issue that exists right now with existing invisible interfaces and how we plan to solve them. So the first one is private controls. When it comes to audio, imagine that you wanted to text everybody, but the only way for you to type a message is using your voice. Imagine all those embarrassing tests that you would do to your girlfriend or your loved ones, your boyfriends, and now everyone can hear what you're saying and what they're saying. On top of that, as soon as you prompt for a command, multiple phones around you would activate. Right? This is a key issue right now, which is that current invisible interfaces don't really allow for private control. That's even the case when we're talking about gesture. Right now, for example, if you're using an augmented reality system, like a Microsoft HoloLens, you would raise your arm, you make other grasping motions, and one, they have accuracy issues, but then two, doing that over a long period of time can get very exhausting to hold your arms up and click on things. Or if you're talking about something more commonly used, for example, TikTok, you have to make incredibly large commands that are visible to others and that are incredibly disruptive before the system can actually recognize what you're trying to send. The other issue is intuitive controls for audio. So imagine right now with an Alexa, you want to order something like a toy Yoda, and it misinterprets you, right? Now, obviously, with a Alexa right now, it wouldn't order you a car, but you can start to see how correcting it when it gets something wrong can become an incredibly cumbersome task. Right now, when you talk to somebody directly and they misinterpret you or they mishear you, you can actually just say, actually, what I meant to say was X. And they're able to understand you. But when you're talking about a device like an Alexa or Siri, you have to restart the entire process again. And this creates a huge barricade for users and makes them actually want to use their technology less and less. And the next one is creating proactive actions. As we start moving toward more mobile technology, we're going to get a plethora of information thrown at us. For example, here in this phone, tons of notifications are coming to a person. Now imagine how much worse this could be if somebody had an augmented reality device. They could walk down the street and every single store could bombard them with marketing materials, coupons, ads, etc. And really, as our technology becomes more mobile and we can move it everywhere, it becomes an avenue for bombardment of information. So how do we solve these issues? Well, the way we can solve them is something called a brain-computer interface, or a BCI. A BCI is anything that can help you understand human intent. So whether that's an electroencephalography sensor, or EEG, that records brain activity, sensors that record muscle activity, accelerometers, heart rate sensors, heat sensors, etc. All these devices can be used to understand what a human is intending to do. And by doing that, we're able to command a device in order to provide the user controllability. Now, brain-computer interfaces have an incredibly large scope of which they can contribute to. The most commonly thought of brain-computer interfaces are used for conscious control. So when you think about a brain-computer interface, it's usually like a prosthetic limb that somebody's using their brain activity. But it can be used for anything, for example, such as augmented reality or any type of device where you want to directly control something. However, there's other areas as well too. For example, enhancing existing technology. There's actually brainwaves that can help us understand when something that you heard is incorrect. And so in this case, you could tell Alexa to order you something, and when it misinterprets you and says, okay, ordering this item, and your brain knows that that item is wrong, we can actually send that information back to Alexa and help correct it before you even say the next word or you retell it the command. And so you can see how we start enhancing existing technologies and creating more intuitive forms of control. And then the third one is effective computing. If we can understand a person's cognitive state or emotional state, it enables us to do things for them. It enables us to understand, hey, this person is trying to focus right now. Maybe we should turn off the notifications on their phone. This person is hungry right now. Maybe this is the time where we should send them an ad for a nearby restaurant instead of, randomly throughout the day, which is how current notifications are done. To us, the future of brain-computer interfaces is just a small wearable that you put inside your ear, a pair of glasses, or a pair of headphones. It doesn't look out of place, but it gives people a higher level of capability to interact. And that's why we need invisible interfaces, because if it's something as small as an earbud, we won't have a screen for them to click on. And if we do, they might as well be using a phone. Now, to talk to you about how brain-computer interfaces are really going to create the next step in human interaction, I need to describe to you the different levels of user interfaces for invisible systems. So when I was talking about voice and gesture, I was talking about systems that do things by your command. So you tell them something, and then they do the action, right? By your command, the action happens. However, brain-computer interfaces have the ability to start doing things with you. So in the case of a conscious control system, when you want to consciously grab something, it'll grab it for you. It does it with you. And then finally, it can do things for you, understanding your cognitive state, how you feel emotionally. For example, if you're focusing, it can turn off the notifications for you without disrupting your flow or making you have to click anything yourself. In the next section of my talk, I'm going to talk about level 2 and level 3 and how brain-computer interfaces enable us to do this with some real video examples. So the first one that I'm going to cover is level 2, brain-computer interfaces that work with you. Now in this case, we're talking about devices like conscious control systems. I'm going to show you an older system that we had that enabled people to actually interact in real time using their brain activity. So in this video here at a conference called MTech, I actually have one of our founders, Adam Molnar, and he's wearing a virtual reality headset that has electroencephalography or EEG sensors on the outside strap. And what he's able to do is look around this virtual environment, and there's a lot of objects, and it's an escape the room. So he has to actually use the objects in the room to be able to escape. And what he can do with our signal processing pipeline that interprets brain activity is whenever he consciously wants, he can pick up an object or he can throw an object. And all this happens in real time. And he can use these objects to be able to actually escape the room. So here he's throwing at this little triangle, but next he's going to try to find the clue to the room, and he's going to break this glass in order to get the code. Now these are very simple commands. Here he's basically just doing one click at a time to type on a keypad. But just like a mouse has the potential with only one click to do so much, we can start doing the same thing with brain-computer interfaces. And the fact that we can do this so reliably is really what Neurable secret sauce is when it comes to signal processing. But now imagine bringing this to wearable technologies and allowing people to interface with that level of speed and accuracy. And this also touches on the future evolution of interfaces. So in the past, in order for us to interact with our technology, what we needed to do is have some sort of hardware like a mouse. We'd move the mouse physically, and that would enable us to control the computer. But as we become more and more mobile, we need technology that integrates more deeply with an individual. Take, for example, the smartphone. Now there's actually a screen that we directly touch the command into. And as we move even one step beyond the smartphone, now we're talking about technology where the actual mind of the user and the technology are one system, where they're able to work together. And that's the potential that brain-computer interfaces have to bring. The next thing I'm going to talk to you about is technology that works for you. Now this is incredibly exciting, and it's not something that typically people think about when they think about brain-computer interfaces. But imagine that you could have a piece of technology that could, in the background, do actions for you and make your life easier without you even noticing. So in the next example, I'm actually going to show you a prototype that we've been working on with some partners, where we're actually changing the difficulty level of a training exercise for an individual. Here they have a box sorting application, and the more difficult that the experience becomes, the more challenged the user is. Now the problem is if you make something too difficult, they will become frustrated and they'll give up. But if you make things too easy, they'll become bored and they'll also stop playing the game. And so by understanding how a user is experiencing the challenge of the situation, we're able to tune the difficulty to help keep them in their best learning environment. Or imagine a wearable that you put on your head that is able to understand when you're ready to focus. For example, there's a light on the outside of your headphones, and that light can let others know when you need a break. So it can turn green and say like, hey, this person's fatiguing out, maybe somebody nearby can come by and ask them to go for a walk and grab some coffee. Or it can turn red, and this person is now focusing, let's leave him alone, let's let him get his work done. And that's not only good at communicating outwardly, but also imagine it in your daily life. Imagine being able to create more time in your day because you know when you're focused, and you won't be disrupted when you're focused because your notifications are turned off automatically. Now this touches on something that we like to call the everyday BCI. It's something that we work on at Neurable all the time. Thus far, there has been no consumer brain-computer interfaces that have really scaled. And the reason for that is anything of value requires incredibly high cost at this point. And any brain-computer interface that is affordable provides so little value to a user that it's not something that they use every single day, and it brings them some sort of continuous value. So at Neurable, what we're doing right now is we're building something that we call the Everyday BCI. It's a small wearable device that gives people value every single day. And we believe that this is going to be the future of brain-computer interfaces that really helps them break out into the mainstream consumer market. And we're going to show everyone more of this later on, and I look forward to introducing you to our next product early next year. So with that, I'd like to thank you for spending time with me and learning about the invisible interfaces. We're Neurable. Please feel free to reach out with us to us. Thank you.